In this video, we'll talk about what a complement and set difference are. So let's start with the definition. Let S be a set within some universal set U, the complement of S. And the way that this is written is we'll write an S with a bar on top of it, or sometimes you'll see it written as S and then a C kind of written as exponent. That stands for the word complement. The complement is the set of all elements in U that are not in S. So visually, if I have this rectangle that represents my universal set U, and then let's say the circle represents S, the complement would be the stuff outside of the circle, but within the rectangle. So outside of the circle, but within the rectangle, that would be the complement. So I'm shading it in. All of this stuff, that is the complement. So as an example, let U be the universal set that consists of the integers from 1 up to 10. A is the set that contains 1, 3, 5, 7, and 9, and B be the set that contains 2, 3, 5, and 8. I want to write B complement in my set roster notation. So B complement, let me put my curly brackets, consists of all things in the universal set that are not in B. So those are the other integers that are not in B, like 1 and 4, as well as 6, 7, well, 8 is already in B, so that wouldn't be there. 9 and 10. Those are the things in U that are not in B. Okay, nice. All right, so we're ready to define the difference. The difference of A and B, and the way this is written is two common ways. Either as A minus B, or sometimes we write A and then backslash B. This is the set. The difference is the set of all elements that are in A but not in B. So visually, if I have a circle for my set A and then a circle for the set B, and then I draw that within my universal set U, the difference would be the part of A that's not in B. So that would be, ooh, didn't mean to erase. So the part of A that's not in B would be this stuff. Okay, cool. So that is the difference. All right, so let's use our example. So U, A, and B, let's say they're the same sets we were working with before, but now let's write the difference in set roster notation. So A minus B consists of those elements that are in A, but they're not in B. Okay, so that means 1 would be there, because 1 is in A, but it's not in B at all. 3 and 5 would not, because they are in B. And then 7 and 9 would be, because they are in A, but they're not in B. Awesome. Cool. So we got the difference here for this example. So there's a key theorem we can state about the difference, which I'm going to illustrate visually. So imagine we have our circles for A and for B, and they're within this rectangle for my universal set U. So one thing to notice about the way that the difference is defined, it's the set of all elements that are in A, but not in B. So the word but is just a synonym for the word and. So the set of all elements that are in A and are not in B. And the word and means an intersection. That's where I'm getting this intersection symbol. And it's an intersection of, the first part says elements that are in A, so that's going to be the first part, in A, and at the same time they are not in B, which means the complement of B. So visually, why is that? So if I were to first draw just B complement would be the stuff that's outside of B, but within the universal set rectangle. So all of this is outside of B, but within the universal set rectangle. Okay, and now I want to take the intersection of that with A. So when I take the intersection of that with A, let me draw my universal set again, and A, and B. I want to take the overlap of that with the circle that represents A. And when I take the overlap, it's just going to give me this part here, the overlap of the A circle with the green shaded region. So I'm going to shade that in, shade that in, and that is A intersected with a B complement. It's the same thing that we were shading in here when we shaded in the difference. So that visually shows why we'd expect these to be the same. Okay, so I want to end this video with one final example getting some more practice with drawing Venn diagrams using some of these definitions that we now have. So this time we have 3 sets, an A, a B, and a C. So I will draw 3 circles, A, B, as well as C, within my universal set rectangle. And I may need a couple of steps like I needed here. So let me draw a second Venn diagram. So I'll copy this one to the side. Okay. And in the first one, well, one of the things I notice is I have the union of 2 things, but let me start with a more complicated one, B minus C. Let's draw that. So B minus C would be the stuff that's in B, but that's outside of the circle C. So that would be this region, in B, but that's outside of the circle for C. Okay, that's B minus C. And I need to now take the union of that with A. So A consists of everything in the circle for A, and with the union, we shade in everything that's in A, as well as everything that's in this green region, this difference, all of it, all of that gets shaded. So let's do that. Let's shade in everything in the difference of B and C. And it's also shaded in everything that's in the circle A. So shading in everything in the circle A gives me all of that. And that is a union B minus C.